go.
So, yeah, okay, from the chat. Okay, that's good, Shraddha. Okay. I mean, I'll keep it fairly simple. I'll try to explain each and every steps as much as to the best of my capabilities. And feel free to ask doubts or stop me in between to if you don't understand anything, I'll be happy to go over them again. Now, is there anyone of you who have not attended the first session? I'll give a brief recap of what we discussed in the first session and what RAG is. So, in the first session, we discussed that RAG is basically an open book architecture for LLM. That's an analogy I try to look into, and that helps me imagine visually what RAG architecture is. So, I like to think of so when you're giving an exam, there is a question that you're asked in the exam, and you have to write an answer to it. But obviously, our brain is not, you can't remember everything. You're bound to forget anything or, mistake something or, hallucinate in your brain. So what we have is a cheat sheet that we have with our exams. That is something that you make on your own, which is friendlier to you and you understand it the best. It can be a note, it can be a 50-page note, it can be a one-page cheat sheet. And then you understand that, you look through the answers from that cheat sheet and answer the question based on that. So I like to think of RAG as this analogy that you have your cheat sheet, which is converted into a vector store. And now an LLM is more convenient and it's more easier to pass through the cheat sheet in a numerical format. So we convert the nodes, we convert any text, any CSV that you have into a vector embeddings, which you store it in a vector store, which is the cheat sheet for your LLM. And then LLM parses through that cheat sheet, finds the most relevant document from that, and then takes it as a context and answers the question based on that. So today we're going to build a very basic RAG application to show you how you can build your own. And then I'll also give you a quick tips and tricks on how you can deploy it using Streamlit as well. So I will share a file with you, which you have to download right now and follow through with me. Okay. Um, the file. Once you all have downloaded, let me know. Then we'll move ahead. I will share my screen till then. Okay. Can you see my screen?
Yeah.
Okay. Perfect. Can you see the Zoom screen as well, or no? Like side panel of you guys in it? No? Okay, cool. That's perfect. Okay. Um, so I'm guessing you guys have downloaded the document that I've shared. So to start with, it's an IPYNB notebook. That means it's a Python notebook, which will help us run the code. Now, one of the prerequisites was to have a Google Drive account. So I think all of us use Gmail nowadays, and I think Google Drive is fairly simple to have with if you have a Gmail account. So the first thing we're gonna do now, I like to be very organized, so I like to create a folder whenever I'm doing something new or it's a topic. So I'm gonna create a folder tag demo. Once the folder is created, I'm gonna upload this file over here. So uploading is very simple. You just go to the plus sign, new sign over here on the left side, and you do a file upload and please know where you are storing your IPYNB notebook that you are downloading and upload
So,
it here.
Zeba, you want everybody to do this side by side, right? So
Yes, yes,
everyone please follow along.
yes,
If and I think we'll have to pause every time to see if everybody is
yeah.
uploaded. Yeah.
So I'll keep like whenever you're done with a step, please do a thumbs up here so I'll know that you all are done. And then we'll move to the next step. So are you guys done with this step? Are you guys uploaded the IPYNB on your Google Drive?
I think everybody's still.
Okay. Yeah,
They were
no
just.
worries.
Yeah.
If you have an issue, just open your mic and you can just let me know. Okay.
Yeah, sorry. I had the meeting on my iPad, so I need to switch to a laptop. Okay.
Yeah,
So
no
before I
worries.
download it, thank you.
No worries.
So Sherry, I think if it's not opening, that's okay.
Yes. No, it won't open in text file. It's a very specific IPYNB notebook. Sorry, I'm not monitoring chat that
Yeah,
regularly.
I'll keep an eye on it.
Yeah.
Um, so if you
So
finished, yeah, thumbs up. Okay.
yeah, just upload it. I'll show you how to open it. We'll open this file pretty soon and you get to see what's inside this file. Is everyone done? Like, do anyone need to me to wait? Like, please be free to stop me whenever you are stuck anywhere. Like,
We just want to make sure everybody's done, right?
yeah,
Yes, kindly reshare the file because it looks as
yeah,
if it cut off my session or my messages when I linked here.
sure. I will
Thank you.
send it again.
Mhm. Yes, thank you.
Is everyone done?
Yeah,
Of
Yes, thank you.
okay.
please
I'm
add
gonna
a
move to
thumbs
the
up.
next step.
Yeah.
If anyone is stuck, just feel free to stop me, okay?
Okay.
So to open this, we are gonna use something called as Google Collaboratory, which is a software that we're gonna start in our drive right now. We're gonna install it on our drive. Now, how to do it? If you click on the three dots here, it will say open with. Now, I already have it installed on my drive. That's why it's showing me here. But for many of you, it might not show. So just go to connect more apps here. And on this, just search collaboratory with a single L. And you'll see this over here. Is anyone able to, everyone able to find it? Yeah. And just install that app on your Google Drive. It will automatically install. Probably you don't have to do anything.
Can you try
Yeah,
repeat
I
that,
can
please?
go
Hmm.
back again.
Please.
The three dots here, open with. If the Google Collaboratory is not shown here, go to connect more apps. In the search, just search collaboratory,
Okay.
and this is gonna be the app that we'll be
So we
using.
should have saved the file in the Google Drive.
Yes, upload it on a
Okay,
Google Drive. You can make
got
a
it.
folder if you like it more organized.
Okay.
But yeah, yeah. Is everyone done?
I think we'd like people to at least give a thumbs up or something in the chat, please, if you're
Okay.
done.
Okay. Okay. I'm gonna move to the next step. If anyone is stuck, just stop me, okay? So once you have it installed and you again go to Google Open with, it's gonna show it here that it's an installed app and you can just click here and it's gonna open the notebook. And voila, you're in Google Collaboratory notebook. So I'm guessing everyone is here. I'm gonna do a quick demo on what this interface, what this environment is like, so everyone knows where to look for anything. To start
Okay.
with, yes,
Question, please. I'm sorry.
yes, no
When
worries.
I open the app, the file in Google Drive, um, you mentioned one step where you said connect.
Yes. So, can you do open with? And can
I
you see
did.
Google Collaboratory here?
Okay, got it. Open with then Google Collaborate.
Yeah. Yeah, just click on that. It should open the notebook. So, Yeah, it needs a special software to
So
open this
I
type
don't
of
see
notebook.
Google Collaborate on mine. So
Okay,
just to connect more apps.
yes. And then search here collaboratory.
Okay.
And this is gonna be the app with a yellow CNO.
Collaboratory. Interesting. Okay, I found it.
Yeah.
Collaboratory. And then it's gonna be the yellow one. Okay. And then
Yes, just
install.
installed it. Yeah.
Okay.
Then if you go back, you'll be able to see the app here.
Oh, okay.
Okay.
Hmm. Okay.
So what we are doing here is we are on a cloud platform. Now, Google is a cloud platform. There are two ways how you can run a code. One is you can run it locally, and one is you can run it on cloud. So what does this mean? When you say you're running a file locally, that means you're using your computer's resources, and your computer is gonna work overtime to run that code for you. But when you think of running it on cloud, that means none of your computer's resources are getting used, but whatever that is available on cloud, those resources you're using either through free or paid version. Right now we are in the free tier of Google Collaborate, so nothing is charging us for running this file.
Okay.
And that's why you say that when you're running a lot of heavy files, when you're running a lot of neural networks file, you need a lot of GPU and CPU power to run this, the processing units that we say, processing power. So that's why a lot of companies invest so much into this. That's why there are NVIDIA chips for that, that supply you with this processing units, which your system is incapable of having it in-house. So that's why you do it on cloud or using connecting a lot of chips to run these powerful files here. So now what this Google Colab is, so on its interface, you can see that I have a lot of text written here. So that's something called as a markdown cell. So what a markdown cell means, that I can write this text. If many of you, I think some of you are familiar with HTML. So it's like HTML, but with markdown capabilities. So here what it means that I can write this text in a code sort of format. And if I run it, it's gonna display it very neatly, basically. So it's like an in-house HTML file that getting converted into a text format. So if you see, if I have one hashtag here, that means it's the H1, that is the heading one tag that we have in HTML, and it's gonna be the largest font size. And the more hashtags I add here, the more it's gonna, the lesser the font size is gonna be. And similarly, I can make it bold as well. Now, Google Collaboratory has a very good interface where you don't have to know the code and the style on what you need to write. You can just click here and it's gonna bold here. And you can see the output on the right side on my screen here. Okay. And similarly, I can make it italics like this as well. And it's gonna tell me. So that's just a brief. We don't have to worry about this markdown cells right now. But that's something I wanted to tell, that there are two parts. There is markdown and the other is code cell. Code cell is where you actually go and write your code, which will run. So if I come here, you'll see this is gonna be more shaded. Now, if you have a light theme, I'm gonna convert it to light. So it's much easier for you to see. So if you see this shaded part, which I hover into, that's my code cell here. That's it. That is, we are gonna run this part, and this is, if you hover over it, there is a play button here, which will, when you click on it, it will run the code cell. To run this code cell, the first step is to connect it to the drive server. That means that here, when see here connect, just click on it and it should connect to the server of Google, and you'll be able to access their resources, which they have hosted somewhere in the cloud. So if you see here, there will be a green tick mark, which shows that it has been connected to the server. And if you click here, you'll see that there is system RAM available of 12.7 GB and disk RAM of 107.7 GB. That means this is my capabilities, my processing power that I have for free on the cloud source. Okay. And if you want to increase any code cell, if you want to write notes while doing this, you can easily do this. Just hover over this line, which will appear after every code cell, and you'll see this two option of either adding a code cell or a text cell. If I click on this, I can add text here. Hi, I am making notes. And if you want to just press enter, just press shift and enter, and it will run and it will be as a normal code, normal text file that you'll see here. Is everyone following me? Is everyone understanding like what this Google Colab file is and how it's structured? Okay,
Yes.
okay, perfect. Thank you so much. So I have written a lot of things on the text here explaining what each code cell is doing. I'm not gonna read too much into it, but I'm just gonna explain directly what this code is doing. The explanation is there in the text, which you can anyway go back and look and read into whenever you want to. So what we are gonna do, a quick overview. As a prerequisite, we asked you to have a PDF file which you want to query. Now, this PDF file is gonna be like an open book which we are going to ask questions to. And we are going to create a vector database using a vector OpenAI's embedding model from it. And then we're going to create a vector database, which is going to be a Chroma database, which is an open source vector database, which that means it's free of cost for anyone to use. It's available online. And we're going to retrieve the most relevant chunks. We're going to find the chapter which it's we are looking for, get where the answer is stored, and then we're going to answer that question based on that. Okay. Now, the first thing when you do, so imagine this code environment as a kitchen. Okay. To run this kitchen, you'll obviously need appliances, right? So in this kitchen, you'll always have the stove top installed, the sink installed, but then you need some instruments to it. You need a blender, you need utensils to it. So what we're gonna do, the utensils over here is gonna be our libraries. The appliances that we're gonna use, it's gonna be our libraries. So the first thing you do is to install these libraries into your kitchen, install these utensils and everything. That means you buy that and you install it so that it's available in your kitchen over here. So if you see on the first code cell, we are going to use something called as LangChain, which is an LLM framework, a very famous framework, which gives you a lot of encapsulation. That means you don't have to write a lot of nitty-gritty codes, and you can just access the ready-made functions they have written and run the code based on that. So it makes coding much easier for you that you don't have to write everything from scratch. So we are going to use LangChain here, which is a framework which is very useful in creating LLM related applications. We are going to use OpenAI here. The API key that I asked you to get, that's going to be from OpenAI because we are going to use the LLM of OpenAI. The next thing you see here is PyPDF. So PyPDF, because we are working with a PDF file here, so we're going to use this dependency file here. The second thing is tick token. I think everyone knows about the context length and the token limits and all. So tick token is a dependency file which you'll need to run with the main libraries here. And a Chroma DB because we are going to be dealing with a Chroma database here. Okay. And this command, if you see, it says something called as pip install. So pip install is basically a Python installer, which can help you install all these libraries into your kitchen. So this pip install, you can think of it as some handyman or someone who knows how to do this and will take that work for you, take that work on of you, and it will do it for you. So if you hover over this, if you click on this code cell, you can write anything into it, and you can just run into it by clicking on this play button here. So if I do click a play button here, it's gonna install the all the libraries that is there for me in this notebook. So everyone just click on this play button and this libraries will be installed in your environment. It's gonna be a lot of text. You don't have to worry about it. It's just printing out the progress of how much it's installing. It's gonna take some time. Okay, so I got a warning here, which many of you will get. I tried to solve it, I didn't know how to do it. So if you get this error, just click on restart session here. That means what is happening is I think I had it installed on my local and it's giving you an error right now. So just click on restart session. And if you see here that it's gonna restart this whole session, that means it's gonna reconnect again to the servers. And you again click on the play button here and it should run now. Is everyone done with this running of code chunk? And when it's run, you'll see a green tick mark here saying that it has run.
Mhm.
Is anyone stuck in this part?
I got to the point where I need to restart session, so I'm
Yes,
running it again.
yes. It's gonna take like 7 seconds. You can see the runtime as well on how each code cell is taking.
Mm.
So yeah. Is anyone else facing an issue or need to go back to anything back?
Okay, mine is done with an with a green check mark by the play.
Okay, perfect. Is everyone able to follow through?
Yes.
Okay, perfect. I'm moving forward. If anyone is stuck, let me know. Okay. Yes. So the second thing is you bought these appliances to your home. So now you have it in your kitchen, but you still have to plug them, right? You still have to put it in the electronics port saying that, okay, now you have to actually supply the electricity to this event, to these utilities and run this devices, right? So what you're going to do is something called as import libraries. So importing libraries is basically just plugging it in our kitchen, plugging all these appliances. Now, there are two ways how you can do this. The first is to directly write import. That means import everything. So if it's a blender set, suppose, so a blender set has so many different varieties. Like it has a smoothie maker, it has like a smoothie utensil, it has like a chopper, or there are different things that comes in a package. It's a set, right? So you put everything to the electronics port and use all the resources that is there, or you can optimize it. You can make it more efficient. So what you can do is, so at a time, if I want to just make like a sauce, I just need to use that sauce pan, sauce vessel, and then you just want to import that part of it. So if you see here, there is something called as from LangChain, and in LangChain, what I'm talking about, the document loaders. So the way they structure the libraries is they try to make it as organized as they can. So it's easier and it's very intuitive for you to access these core functionalities. So LangChain has different things. As I said, it's an encapsulation framework, right? So it has different things starting from to loading the documents to splitting it, creating embeddings, storing it in a vector store, and then having things like that. So here what it's doing is within LangChain, there are document loaders. And from document loaders, I want to deal with only the PDF loader because I'm dealing with PDFs here. Similarly, from LangChain and the text splitter section in that, I want to deal with only this text splitter. And similarly, you can import all these necessary import files that are there. Got it? And this is how you are plugging all your devices in and you're ready. Now, the next thing I told you to do was to get an OpenAI API key, which I'm guessing all of you have gotten. So there is, as you can see, your API key here variable. So just replace your API key with this thing here, with this variable. So I'm just gonna get where my OpenAI API key is stored, and I'm gonna plug that API key. So as you can see here, I've put my API key here. Is everyone done with this part? So till you all are doing, I'm going to explain what an API key is. So API is basically, I like to imagine APIs as a waiter in a restaurant. So if I'm going and if I'm ordering a burger, then the waiter is going to take my order, go to the kitchen, fetch that order back to me again. So it's like a waiter, which is you're gonna give it some things, you're gonna give it some credentials, you can give it what you want from it. It's gonna go to the servers, it's gonna go to the OpenAI servers, and it's gonna fetch what you need right now. So it's like a waiter which gonna go back and forth, and it's gonna be an access that it's gonna give us. So here what I'm doing is in this OpenAI library, I'm storing it as an API key here. Okay. And once you're done with this step, make sure that there are inverted commas at the front and the at the last part of it. That means it's a string. It means it's a text file here. And then you're going to again click on the play button here, and it's going to run this code cell. You can see a mini arrow which shows where where each line is running right now. So as you can see, this part has run. So we are done with importing our libraries as well. Is everyone done with this step?
So what do we do after we paste the key over there?
You're done. Make sure that you have inverted commas at the front and the last part of it, and
Uh-huh.
then just run the code cell again here using the play button. The shortcut is to click on the code cell and press Shift plus Enter
Okay.
together. So you can do that as well. It's
Okay.
quicker if, yeah. So till now, whatever we have done is basically setting up our kitchen, setting up our coding environment here. We have got our appliances. Now it's time to start cooking. Okay. So the first thing is gonna be uploading our PDF files. Okay. So how are we going to upload it? So if you see here, there's a file folder, file icon here. I'm going to click on that. So this part is where you can upload all your local files here, which you can access it in your coding environments. So I'm going to click on this upward arrow here, which is upload to session storage. You guys can see my arrow point, right? Yes. Okay, cool. So I'm going to click on this. I'm going to find where my PDF file is, wherever you guys have stored it. Just find that, and I have it here. It's gonna be the same file I had. You're gonna be shown a warning which says that ensure that your files are saved elsewhere, because when this session is gonna be deleted, whatever you have stored in your session is gonna get deleted. It's a temporary storage, so it doesn't use any of your like process powers in any way. So just do okay on that warning, and when your file is uploaded, you'll be able to see it here. Is everyone done with uploading their files?
Yes, I'm done.
Okay. So now here you'll see there is something called as PyPDF loader. That is, whenever you're dealing with a file type, we want to load this in our environment. We want to load this from this file section to our code file here. So how are we going to use? So LangChain has something called as document loaders, where you, based on what your file type is, you can adjust the loader here, and you just have to give your file name here, and it's going to take care of the rest of the things for you. So here, whatever your file name is, just you can just go here. If you go here, there will be a three dots here. If you click on it, there is something called as copy path.
Mhm.
If you are too lazy to type anything, just do copy path. And whatever is here, just replace your PDF path.pdf completely with this.
Mhm.
So that's where we're gonna initialize it. So this is something called as initializing a function. That means you're making sure that the plug that you have put connecting your device to the electricity port, it's working fine. So that's how you're initializing it. So
Quick
now when
question.
you, yes.
So I see PDF loader. Where is that?
So it's a PDF loader. So it's gonna read your PDF and load it as a variable
No,
here,
I
which
mean
you
I'm
can
trying to
access.
see where mine is. Oh, I see it. I see it. So copy and paste
Name. Yeah.
the file. Okay.
Yes.
PDF load.
Whatever your file, were you able to upload it over here?
Yes, I was. I
Okay.
did. I
Yeah.
did.
Either you can do that or you can just hand type your name as well. That should be fine.
Okay. All right.
And once you initialize it, you'll see a dot load function here. That means turning on your device. That means it's gonna load your PDF into this variable called documents here.
Okay.
So when I run this, it's gonna run very quickly if your document is small.
Mhm.
And I'm gonna close this section because it's coming in between. And if I want to see this document, so if you see here, there are different types of functions where you can see how what details about this variable. So if I type here and do a documents in the parentheses here. If I run this, it says it's gonna be a list. It's gonna be a list. It's gonna break my documents page wise and it's gonna load it as a list. Now, if I want to see the length of this list, like how many pages my document is, there is something called as len function, which is just len, short for length. And similarly, if I just put here len and documents, it's gonna show me that there is 6 pages and it's loaded as 6 different documents in this environment. Now let's see what this document looks like. We're talking about this and how it's gonna get loaded. We are gonna see this.
Could
So
you
it's an
quick
yes,
question? Could you please repeat from where we pasted the PDF?
yes. Once you put your name of the PDF here, just press
Uh-huh.
on the play button. It's gonna
Okay,
run that and load that PDF for you.
I did. Okay.
Then, as I told you, like we can add another cell here. So if I just hover right below, I can see two options here, plus
Oh,
code or plus text.
uh-huh.
If you want to check some details about your files, like you can access your files here, but if you want to just, see the file details on the code here, you can see there is something called as type and documents. You can just type
So,
this code.
so the code and text, just click on code.
Yes, it's
Okay.
gonna add a text
Okay.
uh, or a code. You want to have a text here. I'm gonna copy paste all the things I'm writing here so
Mhm.
that it's much easier for you to just copy paste it. And if you just copy paste and run this, it's gonna show you that this document is a list of separate documents. Len is a function that calculates the length of this list, and this documents, and then zero, that means so imagine this as a to-do list of yours where you number it from 1 to 3. So in Python this numbering starts from 0 and not 1. So if I want to check out the first document, I'm just going to put 0 here, and I can see the first document here. Now if you see the format of this document, there are two main variables that you want to see. The first is the metadata, and the second is going to be the page content here. So what does this metadata mean? If you guys remember, we talked about the evaluating a RAG um, architecture. We saw something also as groundness, right? That means how grounded my answers are to the documents of it. Like we want to make sure we can source the answer that we are getting back to the document that gave this context to me, right? So if the question is about World War I, we want to be able to trace that back to the chapter which talks about World War I, right? So this metadata is going to help us. It's not useful. It's not going to be useful in writing the answer, but it's going to be very useful if you want to trace back your answer. Like if you have multiple documents, if I have like hundred thousands of documents, this metadata is going to tell me that the source of this document is this file. There are total number of pages, and this document basically deals with the page zero of this, like the first page of this. And the page content is just straight up gonna be the content of your pages, right, in a markdown format.
Mhm.
So similarly, you can see that there are other documents. If I just replace it with one here, that's gonna be my second document.
I
So we
don't
have loaded.
Quick question.
Yes.
I don't see my documents though.
Did you run this code?
The code, the PDF that we loaded.
Yes. Is
I did.
that ran? It ran? Can
Yeah.
you type
Let it
documents?
run 1 second.
Yes.
So type documents.
Yeah. It's gonna show you a list here as an output.
Steve, a quick question. Did you
Yes.
say that the format should always be in Markdown for the documents that are uploaded into the
No,
RAG?
no, it can be
No.
any format. It
Okay.
can be fine. It's gonna read as Markdown, but it can be any format.
Okay. Thank you.
Okay. It did. It
It ran.
ran. Yes,
You
thank you.
are you able to see your document here?
Yes, I am. Thank you.
Okay, perfect. So the next step is to chunk it. That means you split the document that you have into smaller size of chunks. Now, what does chunking mean? We talked about chunking a little bit in the first session. It means breaking down your big documents into smaller parts, in smaller digestible parts. So it's like breaking down your whole textbook into different chapters, and
Mm,
then they have different headings into it. Now, why do we do this? The first is main reason is basically to match the context length of an LLM. So we don't want to be exceeding the length that is available through the LLM. Like they have 30,000 tokens or 128,000 tokens. We don't want to exceed that amount that is available for us because it's gonna charge more if you use more tokens of that LLM, right? The second issue that you're solving here is something called as lost in the middle problem. That's a very common problem with an LLM that if you give it a lot of text, it sometimes reads the starting paragraph of it very well. It's reading the last paragraph of it very well. But the middle section of that PDF, it sometimes just parses through it very quickly and does not understand it completely. So by giving it in smaller chunks, we are making sure that the LLM is understanding what is happening and we are not overburdening our LLM with a lot of information at one time. It's like human. Like I like to think of LLMs like human. Like what do I like to do when I'm reading or understanding anything? So just treat it like that. Okay. So we're going to use something called as recursive character text splitter here. So now there are different types of text splitter as well. Like at each, as I said, that each point of your RAG architecture, you can optimize it, you can change it according to your needs. So what you're going to use here is a recursive character text splitter. That means that it's going to split your document based on characters. And we're going to define the chunk size here. That means how many characters I want each chunk is to be, and we're going to do something called as chunk overlap. So what does that mean is if I say two sentences, my name is Zeba Karkhanawala and I love to cook. Now, if I see the obvious two chunks here, that is my two sentences, if I just see the second sentence on its own, it does not make any sense. Like it says like, and I love to cook, but who is I here? And why is there an and there, right? It makes no sense. So we want to have some continuity between different chunks so that the LLM, if it gets some chunks, it should know that, okay, like this is the flow of the statement. So it's not on its own, it should stand, it should mean something, right? So if I see here, so if I have like a chunk overlap of maybe two words, so it's gonna say Zeba Karkhanawala and I love to cook. So okay, the LLM now understand that okay, it's this I person here is Zeba and she loves to cook, right? So we're trying to maintain context here. Okay. So recursive character text splitter. Now there is something called as character text splitter, which is basically it just splits it. Now recursive is basically it's gonna start with your paragraph. It's gonna start with your page first of all. It's gonna break it into paragraphs. There are obvious paragraphs and it's gonna see, okay, like is each paragraph matching my chunk size limit? No, it's gonna break even further. It's gonna go into the sentences of it. It's gonna check, okay, like is each sentence making, if I take three, four sentences together, is it matching my chunk size? No. So it's gonna go even deeper. So it's gonna recursively decide which level of granularity is best to match this chunk size of it. Okay. So here we're gonna again initialize our text splitter, initialize it with two parameters here. The chunk size, which you're gonna set it here as 500, and the chunk overlap, which you're setting it here 100. So this is a completely trial and error part on you guys. You can keep it 1,000 and an overlap of 200 chunks, characters, and that's fine. Based on whatever you have to, try it one or two times to get it right. So on an average, I like to have it as 500 and 100, or either 1,000 and 200 of an overlap. So if you initialize it, and then you ask it, okay, text splitter, now split my documents, which is stored in this document variable,
Okay.
and then we're going to see how many chunks it's going to create here. So if I play this, you can see that it's creating 26 chunks out of my document. So for all of you, this number is going to be different based on whatever how long your document is. Now, let's see chunks here, right? Let's see. So if you see the type of text chunks, it's going to be again a list. It's going to be a list of even smaller chunks here. So I'm gonna give you guys the code so you guys can run it as well. Now let's see the first text chunk. Okay, let's see the first text chunk here. You can see this is my first text chunk, which is the first part of my document. And let's see the second text chunk here. Okay.
Hmm.
So the one thing you'll observe here is there's an overlap. We define an overlap of 100 characters. So if you see this page content of my first document and something along this line, that AI agents developer, Vergent AI, research assistant, AI agents this. And if you see my second documents page content, it starts from agents, RAG, LLMs. So basically where this is ending, it's not exactly starting from that. It's starting from a little before that. So as you can see, there is an overlap of characters here, right? Does that make sense? Is everyone with me?
Hmm.
Is anyone not understanding anything or want me to go back to any step?
Um, I after I got number of chunks 32. So afterwards, did you add a code or text too?
Yes, I added a code, which is
Okay.
basically we're again seeing the type of this text chunks. I'm just showing you how this is gonna, you can see more of what your variables are, what type of variables are.
Okay.
So I'm just doing it to explain you. It's optional for you to do. Like your code will run just fine if you don't do this. It's
Okay.
completely fine. Okay. So this part makes sense. So now we loaded our document, we split it into chunks. So the next part is to creating our cheat sheet, creating a cheat sheet that's readable by an LLM. So we're going to create a vector embeddings now. So here we're going to use an OpenAI embeddings model, which is going to use your API key to establish that connection. So if you guys remember that we are using API key, the waiter here is going to take your content, take your all your text and CSV or anything that you have. It's going to go to the server and it's going to create some vector embeddings and come and give it back to you. Okay. Now, why we are using OpenAI embeddings, and that's not the only option. So this is a paid version of an embeddings, but it's the one of the most advanced embedding models that we are going to be using here. So there are some very simple and open source models like FISS, which is by Facebook, which uses a frequency type of a formula to split the text into the with numbers. So OpenAI embeddings here uses a very good neural network that can make this embedding models embeddings very effective and very intuitive for an LLM to understand. So what's this gonna do? Now, again, we initialized it with our API key. So we have something called as Chroma because it's a Chroma vector store. Now we're gonna say that Chroma DB store these documents from these documents. What are my documents? It's my text chunks here. It's gonna be the small chunks here and use this embedding model to convert the text, to convert your document into vector embeddings and store it into a Chroma DB. So this part, this whole line is gonna create a chroma vector database, which is gonna be stored as a vector store here. And the next thing is we are gonna use a as retriever function. Now, what's an as retriever? It's basically we are telling our waiter, like if there's a storage room, which is our vector store, we are making a person stand outside that storage room, saying that, okay, it's your task to retrieve whatever I'm asking you to retrieve from the storage room. So if you see here, there is something called a search type parameter. So search type parameter here is a similarity parameter. That means that if I give it, if it's a storage room of suitcases, and if I say that, okay, I want you to fetch a suitcase which is blue color with silver handle. So it's gonna go and fetch the most similar suitcases to my description and fetch that back to me. Now, what if there are 15 similar suitcases that match the description and it gets that back to me? So we want to make sure that it's not getting all the things back. We want to make sure that it gets only K documents back. So this search argument here, where we are defining the K, is 3 here. That means fetch me the top 3 suitcases that you think is related to me, related to my query here. So it's gonna say that vector store, that means my person who is standing outside the storage room, act as a retriever and retrieve the most similar 3 bags that I'm asking you to. So here we are also initializing it. We are not running it anything. So if you're going to run this file, it's going to give you a deprecation warning. That's completely normal. LangChain is a very evolving library, so it keeps on adding a lot of functionalities and removing functionalities as well. But this code will run fine for now. Okay, everyone were able to run this code. So if you see the vector store here, your cheat sheet is ready to be used. Is everyone able to follow me? Is anyone stuck anywhere?
So
I
my,
don't see, sorry, I
sorry, go
don't
ahead.
see the run button next to initialize open AI embedding.
Okay, just click anywhere on that text and just hover over here.
Okay, okay, okay,
Yeah.
So
okay.
I'm
Yes.
getting an error for the vector store. It says that my quota exceeded your current quota.
Oh, were you able to load money into your OpenAI platform?
Yeah, like I do have a premium subscription as well.
No, you have to load money into a platform for your OpenAI key. So
Okay.
I have, and if your file is too big, it's gonna use some money as well. So if
Mm-hmm.
you go here, if you see billing,
Mm.
uh, if it's less, just add credit balance to it.
Okay.
That should
Okay.
be able to fix it.
Thank you.
No worries.
Quick
Is
question.
everyone able to? Yes.
So, where I see retrieving relevant documents,
Yes.
Why does mine say this code defines a query? What are Zeba's top skills? Should
Oh,
mine also say that?
no, no, that's completely fine. I'm just gonna I wrote it as a explanation of what this code is doing.
Oh, okay.
So it's gonna be a question I'll ask it. So it's where it's no, you don't have to worry about it. It's just explaining what this code chunk is doing so that you can go back and read this again if you feel like it. Yeah.
Okay.
But is everyone able to follow me through this vector store step and able to create a vector store?
Yeah.
Um, yeah. Okay. Okay, I'm gonna go to the next step, which is so now our cheat sheet is ready. So now we want to ask a question and find the most relevant documents based on that. Okay. So if you see here, there is something called as input. That means I'm asking the user for an input, and this entire question is my placeholder here. So when I ask this query, I'm gonna give it to my retriever. I'm gonna give it to the person who is standing outside the storage room that, okay, retriever, get me the most relevant documents based on this query. So if you again play here, it's gonna show you a text box here, which is saying that enter your question in this text box. So whatever your question you want to ask your document, just write that question here. So for me, I'm just gonna write the question. Once you are done, just press enter. And it's gonna finish running the code cell here. Again, you'll get a deprecation warning. No need to worry about it. Is everyone able to enter their questions? So let's see what these relevant documents are. Now we are again gonna repeat the steps. We're gonna ask it, okay, what is your type? Like, what is this? What did you retrieve? So it's gonna say me, it's gonna be a list of documents. So let's look at the first element. Now, the beauty of this is that when it's gonna retrieve, is going to retrieve the most similar document the first. So the first document in your list is going to be the most similar document to your query that you're asking. So if I run this, it's going to show me this document, which is the page 0 of the document. And if you see in my page content, there is something called as top skills. And it talks about my top skills here, which is written in my document somewhere. So it was able to retrieve the most relevant document and give it back to me. And if you see how many documents it returned using the length function, it's gonna say 3 because we set the variable k equals to 3 over here. I'm gonna give you guys the code as well, so you guys can run it.
Okay.
Mm, okay, done?
One second.
Yes. Is everyone able to follow through?
Mm,
Is anyone stuck anywhere?
yeah, I'm stuck where I need to put the code there. So I added the code line, and that's where
Hmm.
I need to put the relevant docs.
Yes.
Okay.
Yes, Temple, you have a doubt?
Yeah, actually, for me, I am getting rate limiting error at the creating vector embedding step.
At this
First,
time.
yeah, at this step.
Okay. Can you send me the error?
Relevant docs.
Mhm. Should I put it in chat directly?
Yes,
Okay. Mhm.
I'm guessing you are having the same error as Shraddha.
Yeah.
So, were you able to top your account off with enough money?
Yeah, yes, I was.
Because sometimes this open embeddings is a bit expensive if the documents are like a very huge document.
Okay.
Like, how long was your document?
My document is 5 pages.
That is strange. Can you check your billing here to see if how much credit balance you have?
Okay, I can check that.
Yeah, like add more balance if it needs though. The main reason I'm using OpenAI is because I think it's a useful tool to have and learn. So I know it's a little paid, but yeah.
So it was free trial. Did we explicitly needed to add money?
Yes,
Okay.
the free tire won't work. You have to have balance in here. Because free tire is basically to use ChatGPT for free. But if you're using LLM, which is hosted on their servers, you need to have some balance in here.
Okay, then I think I'll add the details. After that, it should work.
Yes, it should work. If you have any issues, just reach me out on LinkedIn or mail. I should be fine.
Yeah, sure. Okay.
Okay. Um, is everyone done? So, uh, till now, we are done with the R part of RAG, which is we were able to retrieve the documents that we wanted that is relevant to our question. The second point is A, that is augmenting the retrieving documents into the prompt. So what it's here doing, we have a contextual query here. So what does this basically mean? It's a F string. So F string is basically you can have placeholders. So it's like consider it as a form you're filling where you're keeping that, okay, in this curly brackets, I don't know the value for this, but just take it from somewhere above where it is actually stored. Okay. So what I'm writing here is a context and then curly braces, which is relevant documents, and then backslash n, that means go to the next line, have a query, and then again, what my query is. So I already defined above here because we entered it over here. So I'll also show how this query will look like in some time. But the next thing here you see is something called as prompt with context. So this variable is basically now, if you know about prompt engineering, you'll know there's something called as system prompts, system roles, and user roles and user prompting. That means if I'm using ChatGPT to, write a LinkedIn post for me. Okay, it's like a social media manager for me. So I'm gonna instruct it that way, saying that you are an expert social media manager for me who knows how to write effective LinkedIn post. And what do I want to write post on? Then I'll give it some description that okay, write me a LinkedIn post about my RAG demo session with AY and make it very intuitive and have a call to action to it as well. So what we are doing is two things. First, where I'm asking how I want the LLM to act like, and the second, what is my actual query. So when you're asking GPT to act like something, you are system prompting it. You are making sure that the system is ready to take what your prompt is. You're making sure that you are, making sure that you are instructing your GPT to act a certain way. Now here, if you see, it's a dictionary, it's a list of dictionary. That means it has a key value and a key and a value pair. So if you see the role here, I'm defining it as a system role. And the content here is you are an expert assistant that answers the query based on the context provided. So here you can write anything. You can make it a sarcastic GPT as well. You can write, or you are a sarcastic assistant who always answers in sarcasm and in a very funny way. And your answer is gonna look that way as well. So basically, this prompt is very simple. I've seen so many prompts that are so huge. Like, you have to write instructions about a lot of different things. So you are keeping it very simple here. It's a very basic RAG. And in the user prompt here, we are giving it the contextual query that we wrote over here, that we wrote a form over here. Now, again, I'm gonna click on play button here, and it's gonna run very quickly. And let's see what a contextual prompt looks like, contextual query looks like for us. you can see that context here is all my documents. If you click on the three dots here, you'll see that, oh, if you see over here, three dots, it's gonna give a lot of context, and then it's gonna be query. Sorry, I forgot one thing to do, having a print statement. Yes, this is what my contextual query looks like, and that's the code you can use. So print statement, that means I want it to be printed in a certain way. So context is my all the documents, all the three documents that we got earlier from our cheat sheet. And the query here is my question that I asked earlier. So that's how your contextual query is going to look like. So now what you have done is you have augmented your query with the context that you're getting from your cheat sheet. The last step is the generation. So now what you're gonna do is you're gonna give all this context, all your query to an LLM, and that LLM is gonna figure out that part. So basically you have found your chapter. Now your brain's gonna understand, read that chapter, understand the question, and then write an answer to it. Okay. So what is you're doing? We are calling an OpenAI. That
Mhm.
OpenAI write a chat completion, like create a chat completion using this model. So we are using GPT-4o. If you want to edit it, if you can make it, if you want to make it like a GPT 3.5 turbo, you can do that. You can use any model basically. So I'm going to use a GPT-4o here because it's a very smart model. And in the messages variable, I'm giving it prompt with context. That's basically this prompt that has a system role and a user role here, and it's gonna give it to an OpenAI. And the OpenAI is gonna, so using that API key that we defined earlier, it's gonna go to the LLM server with my question, with my prompt, and come back with an answer. Now, this answer is not in a way that you want it to be. So this answer might have a lot of garnishing and everything with it, like a sauce and a salad with it and everything, a lot of random things. We want to make sure that you're getting the main part of the dish. So why we are doing this thing? So if you see text responses, then you go within and within. Oh, if you go a little bit, you can ignore this. It's just to clearing up your, like if you're ordering any chicken dish, that we want to just go directly to the chicken part and not waste time in the salad and sauces with it. And this is going to be an answer with context. And now we're going to print our answer and query. So if I run this cell, it's going to write an answer for me. Like this is my query, which is here. And what's my answer? The Zeba's top skills include PySpark, AI agents, and neural networks, which is exactly what we got from our relevant documents. Was everyone able to run to this part?
I got an error at right before this, where we had to print. I got an error.
This one?
Yeah,
Why?
I don't know.
What's the error say?
It says syntax error, incomplete input.
Okay, did I give you the right text?
Let me see.
Okay.
Print
Uh,
query.
yeah. Can you paste
Oh,
that again and run it again?
hold on. I think I forgot. I'm gonna paste it again and see
Yeah.
what it is.
Zeba, hey, it's Tara. Just quick question. So unless in the code, uh, you have to specify the specific information you're looking for in the query, if you don't really specify the exact data, that may be in the RAG that you uploaded, will the LLM sort of commingle and generate, to your point, a whole bunch of like the garnish? Is that what you were talking about? Or am I
I'm
off
not
base
sure
here?
I understand your question. You're saying that we don't need a query for this?
If you don't ask a really specific query,
Hmm.
um, because the LLM is already sort of loaded with a whole bunch of knowledge,
Hmm.
will is it possible for the answer to come back, that not necessarily hallucination, but not like generative information that may not be the specific answer or context?
Yeah, it's
you're looking
possible.
for.
It can
Yeah,
hallucinate the answers. So this one is a very basic rack. There are a lot of different ways how you can optimize this architecture. Like I shared a 3-hour video, remember, in the last session from Free Code Camp that discusses a lot of ways how you can optimize it. So there is a possibility that this architecture might hallucinate for you because as I said, there are a lot of hyperparameters that goes into this, like the
right,
chunk
right.
size, the chunk overlap. So you have to go back and forth a bit and adjust it according to a use case. Now I came to this number after a lot of trial and error and saw that this sets my user case here. So yeah, it might hallucinate as well for you.
And to your point, the chunk sizing and the variables, is
Hmm.
that relevant or a direct correlation to the randomness that that comes up with the, I don't know, the tokenization or the embeddings that they choose from through the what is it, like the decision trees and the statistical um, modeling, for lack of a better term, that decides which one is most alike to the answer? Or am I totally off base here?
No, chunk size really does not depend on the similarity search. But chunk size is basically it has like a lot of text, right? So it calculates there is a similarity method. There are a lot of different methods how you can calculate the similarity between your question and your chunks. So
Mhm.
there is something called as cosine similarity if you know about statistics. So it's basically it calculates the angle between your query, which is pointed out as a vector on the back end and all your vector embeddings and the most closest to zero angle that the cosine similarity will have, that means is the most similar one. So it depends on the wordings of the document and not the chunk size. The chunk
Ah,
size is basically to match with the context limit and to make sure that the chunk is making sense on its own.
okay, thank
Does
you.
that answer your question?
I think so. Thank you.
Okay, yes.
So,
So
Zeba, I
if
have a question where you had asked, right, enter input, and then it said, what is Zeba's top skill?
hmm,
Scroll, yeah. So, in there, if we had not asked what is Zeba's top skill, but we had asked, where is the moon? Something totally unrelated, it would still have gone to like like to GPT-4o and pulled out the answer. But because this
yes,
one is specific to the document that we have uploaded, it will go there, and because it's contextualized. Okay.
yes. So there are a lot of ways that you can prompt this as well. As I said, there's a system prompt. So sometimes it you can like also instruct it that if the answer is not there in the context, just say you don't know. That's another prompting thing people do to
Okay.
make sure that it does not answer any irrelevant question which is not supposed to be answered by this GPT that you're building. So if it's a Shopify's GPT RAG chatbot, so we don't want it to answer a question about Amazon, for
Right.
example. So there's a lot of prompting that goes into making sure there is no jailbreaking of this RAG architecture.
Sure. Thank you.
But right now, if you ask anything, it might answer questions. Yes. So if you're able to run to this part and you have a good answer, then congratulations, you have made your first RAG system. And if you have any questions, please let me know.
I was able, thank you. Question.
Yes.
I was able to make to the last part, but then my print section is still giving me an error for some reason.
Okay, just delete the section. That's fine.
Oh, just
Uh,
delete it. Okay.
yeah,
All right. Thank
yeah,
you.
yeah. That's fine. I mean, I just do it to, explain how this looks like for you
Mm-hmm.
to make sense of what is happening here.
Okay.
So, does anyone else have any questions? Because I have something else to say as well.
This is great. I was able to run it.
Yes, so
Yeah.
yes. So if you were in the first session, you remember I showed something of a very nice user interface where I uploaded a file, asked a question, and gave me an answer. So that's called a Streamlit app, which is used for prototyping and having your personal apps hosted there. So this one is a very code, like if you want to, you have to deal with running codes and doing all this things that we did here. But to do it very easily, you can make a Streamlit app out of it. So I'm gonna, Padmini and Uvika are gonna share this access to a GitHub repository that I've made for this demo, where I've uploaded all the files. So if you'll see that there is an IP1B, which you guys are working with right now, there is something called as a Streamlit app.py file, which I've made here. So this basically has more added functionalities. It can deal with any sort of file types, including PDF, Excel, CSV, and doc. And all you have to do is follow the instructions that are there in the README file. So you can do this two ways. You can do it locally, or you can host it on a Streamlit app for free, does not charge anything. It's just gonna use your OpenAI billing credentials. That's it. I've listed down a lot of steps and I'm open to, like discussing this further if you need help with it. But if you deploy it, the easy, and why I'm saying to deploy it, because once you deploy it, it gives you a user interface to, okay, I don't know what is happening. Okay, this one is giving me an error, but I'm gonna quickly run the,
May I ask while you're running that, for the folks on the phone, is this something that is new, completely new to you, or have you guys, is this something that you're accustomed to, just don't know how to do, or like, I just love to hear some market research from those of you who are left on the phone. Is this a completely new concept, or are you familiar?
I've
Or what are you
this is a for I've heard about it within a sales environment,
Mm-hmm.
but I have never doubled into it like this.
Got it. I just
Yeah.
wanted like what because with Virgin, like this is stuff that we're digging very deep into, and I was just curious because either you know about AI agents or you know about RAG or you don't. So it's a very interesting time frame, and since you guys are a sort of some of you are builders, I was just curious what the lay of the land is from your perspective.
This is Tara. Seema, hi, how are you?
Hi.
Oh,
Hi.
I've heard of it because Noelle Russell was kind enough to sort of introduce this architecture in one of her sessions, and I just started learning about it and long chain, and obviously it makes sense. I mean, given the fact that so many of these models, per my understanding, they stopped loading knowledge for a while, and fine tuning these models is incredibly time consuming and expensive. This kind of architecture makes total sense. I guess it's not perfect to Zeba's point in terms of possible hallucinations.
Yeah. No, yeah, Noel's awesome. So thank you for sharing.
yeah, can you see this interface here?
Yep.
Yep.
For, okay. Yeah, so this is something you can make using a Streamlit app, which is a very user-friendly interface. You don't have to write any code on it, and you just have to browse your files and drop your files here, and you can start asking questions on it. So it's a more user-friendly way. You don't have to run any code, and if you're showing it to someone who does not know any coding, this is a much useful way to do it. So yeah, I mean there are a lot of instructions in the GitHub repo. You guys can look through it. I have tried to make it as detailed as possible. But yeah, if you run into any errors, please feel free to reach out to me. But yeah, thank you so
Um,
much.
quick
Yeah.
question: was this GitHub link? Was it in the resources you sent?
No, this one is not. I just made it public this evening. So Padmini and Uvika are gonna share the access. I can just,
Oh,
share
okay.
it right now.
Okay.
I can, you should, chat. Yeah, you guys can access it now, this
Okay.
repo.
Thank you.
Um, Another thing I wanted to talk about was, so I think someone asked about how this vector things work. So for this demo, mm, I'm gonna quickly open up my drive to showcase this. So there's this diagram which I really like when I'm trying to explain what vector embedding is. So if you see this diagram here, it's a very visual way of understanding how this works. If you see that if I all the terms, all the text that you are making, all the documents that you have, they're gonna be converted into numbers, which they can, plot into a very multi-dimensional system. But in a very 3D space, if we look into it, that apple and banana here are closer to each other than cat, dog, wolf to each other. That means the more similar the words are, the more closer they are in the space. So if I map out the angles between these two, it's gonna be very less. So that's how usually vector embeddings and how similarity search work. And yeah, I just want to clear that up if it helps you visualize this anyway.
Yeah, and then that when you query it with kitten, it goes
Yeah,
closer to the
yeah,
animals. Yeah,
yes. So if my query is kitten, it's gonna lie around here, closest to cat, then apple and bananas.
cool.
Mm-hmm.
So yeah, this document is also there on the GitHub repo here. Like there is like what is vector embedding. You can go read into it more detail if you want. But yeah, that is all from my side. Thank you so much.
Awesome. God,
Well,
thank you so much.
Thank you so much.
I'm gonna stop the recording. Just give me 1 second.